Hello everyone, welcome to my Unreal Engine tutorial series on how to create an open world game. So in the first part I showed you how to create a simple character and add the feature to look around with camera like this, so you can look around. And in this part I'm going to explain how to give the ability to move to the character like this, so that the character can move around in your world. Okay, so let's get started. So yeah, this is my current implementation of the game, and for now we can only look around. And if I haven't added any code to move. So the first thing is when I press WSAD, this character should move. So if we open this third person character template in this part, so this is the part which handles the movement input. So here, as you can see, this input axis move forward event and move right event is the ones responsible to get these axis values. That means if I press W, this axis value would be 1, otherwise 0. If I press S, this would be -1. And similarly, if I press D, this would be 1, and if I press A, this would be -1. So yeah, and this is how we get this. This is how we add the scale value, and this is the direction of that value we must apply. So we have taken that like this, and I hope to write a detailed blog post about the math in this function. So for now, let's copy this and take into our character. So that means our human character here. Okay, so this is my character. This has only mouse input, and I'll paste this here. Right, so let's compile and see what happens. Okay, so yes, when I press WSAD, it actually moves, but this does not have proper animations yet. So the next step is how to add walk-in animations. Right, to add walk-in animation, I'll go to Mixamo, and yes, so I'll get some walk animations. Okay, there are a bunch of walk animations, and this one looks better. Okay, and make sure to enable this in place tick, so that we can get the animation that without the movement, and download without a skin. Alright, so I have already downloaded this, so I'm not going to download again. And similarly, we need animations for running, so I'll use this one for running, same as in place, and also another animation to sprint or fast run. So you know, when almost all the games, when we press shift, the character is sprinting, so we can do that with this. So I'll use this one for sprinting. And other than that, we need some other animations like left strafe or walk left, something like this, and walk right. And like this. Okay, so after downloading all these animations, so these are the animations I downloaded, and I'm going to import these animations into my project. So I'll go to my project and create. Okay, we already have animations folder. I'll drag them here, and I'll select this knight skeleton as the skeleton, and I'll import all. Okay, so now we got these all animations, and let's see, yes, we got them correctly. So the next thing is we need something called a blend space to enable animations in Unreal. The reason to use blend space is that when a character working, if we take a human for example, according to the speed of the human works or run, the animation should be changed, but it is not practical to create animations for each possible speed. So therefore we can do some interpolation of animations in between using this feature called blend spaces in Unreal. So let's create a blend space, and I'm going to create, yeah, like this. Select our skeleton, knight skeleton, and I'll call this BSP for blend space walk. No, free walk, because later on I'm going to create something similar to this with a weapon is on hand, right? Okay, and our character, if we go to our character and see here, in this character movement component, the walking speed is defined as 600 units, and max walk speed crouched is 300 units. So therefore I'll in this horizontal and vertical axis, I will name this vertical axis as speed forward, and the minimum axis value, so that means the minimum value that I will be walking. So I am planning to implement walk back function as well, so I will put this as minus 600, and maximum value as 600, like this. Okay, so and I will create, there are 12 divisions, and similarly for horizontal axis I will call this speed side, the speed to the sides, and minimum axis value as minus 600, 612. Okay, so right, so this is our I'll go to my animations folder, and drag and drop this idle stand animation here. So this is the character when it is standing still. Again, I'll go to my animations folder. Oh, I can drag and drop from here as well. Walking for at 0 to 100. So as you can see, now this speeds in between is being interpolated like this. Okay, so next one is 600. I'll add running animation here at 0 600 like this. Right, now for now I do not have any walk back animations. Let's add them later. So but I have this left strafe animation, so that means yes, I'll add it here. Okay, and right one as well, so I'll add it here. So as you can see, these animations are being interpolated in between these defined animations as I move my cursor over in this space. Okay, so now we have this blend space ready, and the next thing is, how do we connect this blend space with our character blueprint? Right, so for now we have specified use animation asset, and we have put this idle animation as the default animation. So I will create, instead of this, I'll use this animation blueprint, but we do not have any animation blueprints yet, so let's go ahead and create one. Animation blueprint, and I'll select this anim instance as the parent class and night skeleton as the skeleton. Right, and for blueprint animation I'll call this BPA human. Right, so this is the animation graph or anim graph. So if you can't see it here or this one, so you can open it like this. Right, so here I will drag and drop the blend space I created into this blueprint animation. So if I connect this output of this blend space into the final animation pose like this and compile, so this will be the final animation, the output of blend space. And if I change the values here and compile, you see that the character is walking. So what we have to do is, we have to drive these variables through our code or blueprint in order to dynamically change the values of these variables, so that we can get a realistic behavior of movement. To do that, I'll first promote them as variables. Speed side, speed forward. Okay, so how can we? Okay, so now let's go back to our human class and select this BPA human blueprint we just created as the blueprint animation. But still we don't get these walking animations because we haven't defined these values here. Right, to do that we need a reference to our blueprint, our character blueprint, and we have to get the velocity of that character blueprint to calculate these speed forward and speed side values. So let's see how to do that. First thing is, in this I'll add this begin play method into our event graph. That means this function will be executed when the game is starting, or when this character is being spawned into the world, right? So here I'll use this try get pawn owner. So this function will return a reference to the pawn blueprint of this blueprint animation is being used. So I'll cast this into a character because I need it as a character, and you will see why later. And I'll promote this to a variable as well, bp character, right? So now this blueprint update animation method, this method will be called in each frame this animation is working. So here first I have to check if this variable has a valid reference. To do that, I'll do it like this, because otherwise if I try to get a reference and do calculations, if this variable does not have a valid reference, it will throw a null reference exception or an error. Okay, so if the bp character variable is valid, we can set the speeds. So how to calculate speed side and speed forward? To do that, I can get velocity of this character like this, and I'll do it here. Okay, but this velocity is in the world space, and also to calculate the side speed and forward speed, we also need the forward vector of this blueprint character, and the right vector, right? Okay, so in order to get this side, I'll first calculate this forward value. So in order to calculate this forward component of this velocity, or the magnitude of the projection upon the forward vector of character, I can do it like this. We can get the dot product of these two vectors, so that will give me the magnitude of the vector that will be projected upon this forward vector. So more information on this topic will be explained in a blog post, and I will post my blog post link in the description below when it is ready. So similarly, we can use a dot product to calculate the side speed as well, like this. Okay, so I'll compile and let's see what happens. Okay, so the character is moving, but there is a small problem. This character is facing forward and he's not looking at the direction this character is moving. So to fix that, I'll go to this human blueprint, and in this character movement settings there is something called orient rotation to movement here. So if I enable that here, so this character will be rotated to the direction he is walking. Cool. So it's working. Right. So that would be all for this video, and in the next video I will do how to enable walking and running, how to toggle walking and running, and also sprinting. So see you in the next video. Bye.